Okie dokie, in this video I'm going to knock out the Unit 2 quiz in preparation for the first exam. In one video, let's knock out these 16 questions. Here we go. The diameter x in inches of a batch of ball bearings is manufactured, satisfies the inequality here. What's the smallest diameter it can have? What's the largest? So from this inequality here, absolute value being less than or equal to something means if we drop the absolute value bars, the stuff inside the absolute value bars, x minus 0.2, will be in between or bounded by negative 0.02 and positive 0.02. That's just what happens. Like if you have absolute value x less than or equal to 1, that means that x has a lower bound of negative 1 and an upper bound of 1. So we apply that here and we have this. So if we solve for x, we add 0.2 all the way across. Let me do it so it's in line. Add 0.2, add 0.2, add 0.2. When we're doing that, it's almost like we're adding 0.20, I guess. So negative 0.02 plus 0.2 is 0.18, less than or equal to x, less than or equal to 0.22. Smallest is 0.18, largest is 0.22. Let's keep it going. Number 2. Find the values of x that satisfy the inequality. So the first thing would be finding the x values that make these factors equal to 0. So we set each of them equal to 0 and solve for x. We add 6, divide by 3, we get x equals 6 over 3, which is 2. For x plus 2 equals 0, we subtract 2 and get negative 2. So this expression, which I will call y, is equal to 0 at 2 and negative 2. Now we need to test values in between 2 and negative 2, to the left and right of 2 and negative 2. So we know that y, or the expression, is 0 when x is negative 2 or 2. Let's plug in a value to the left, negative 3, a value in between, 0, a value to the right, 3. We're going to plug them in to here and here, wherever we see x, and calculate the overall sign of y, the overall sign of this whole expression. When we plug in negative 3, we get negative 9 minus 6. Negative 9 minus 6 is a negative, but then negative 3 plus 2 is also a negative. So a negative times a negative is a positive. So what this means is not just at negative 3 is the y value positive, but really everything from negative infinity all the way up to negative 2 is positive. Okay? So now we plug in 0. If we plug in 0 for x here and here, we get a negative 6 for the first one and then a 2 for the second one. So it's just positive. So negative times a positive is a negative, which means not just at 0 is the y value negative, but between negative 2 and 2, we have negative values. Plug in 3, we get 3 times 3 minus 6 is positive. 3 plus 2 is positive. Positive times positive is positive. So this means that everything after x equals 2 is positive. We wanted to know where is this expression, or where's y greater than or equal to 0. And so it's greater than 0 wherever the y value is positive. And it's equal to 0 at negative 2 and 2. So negative infinity to negative 2, bracket, union, bracket, 2 to infinity. Why do we have brackets? We have brackets at negative 2 and 2 because those are the x values that make the whole expression equal to 0. And we want to know not just where is it greater than 0, but also equal to 0. And it's greater than 0, all the values in between negative infinity and negative 2 and 2 to infinity. So this is our solution to that up there. So let's see if we can do number 3 here. Sorry for the bad formatting. Find the slope that passes through the pair of points. y2 minus y1 over x2 minus x1. That's your slope formula. I expect y'all to know that by now. 5/9 is the slope that passes through those 2 points. y2 minus y1 over x2 minus x1. Let's keep it going. Number 4.